Hello everybody. Today we're going to go ahead and we're going to look at reading and writing files, specifically file streams, when working within Unity. Now, two things I want to say. First, I want to apologize ahead of time. I have a cold while recording this, so you may hear me cough or sniffle, and I just want to go ahead and I'm sorry. I know how annoying that can be to hear that in your ears. And second, I want to say that the code you're going to see today is not specific to Unity. It works perfectly fine in Unity, and using this code in a Unity project should work perfectly fine on Windows or Mac builds. But the code that you're going to be seeing is actually basically what I like to call C# agnostic, meaning it's pure C# code that'll work in any C# project. Now, to go ahead and get started, forgive me if I go ahead and repeat anything you've seen in my previous videos, but just to cover all our bases, here is a fresh Unity project. Now, let's say that while our project is running, either when it starts up, we want to either read or write to a particular file, or when it closes, we want to read or write to a particular file. So, we're going to go ahead and we need to create a game manager, something to go ahead and monitor events in our game, and something that we can attach events to, such as do X when our game starts up. So I'm going to go ahead and right click and do create empty. Again, for those of you who don't know, empties are basically like creating just an invisible object that exists within your Unity scene. And you can go ahead and attach scripts to it. You can have it perform actions. It has a start, and all the scripts have start and update functions just like you would see on other objects, but this object isn't visual. It's supposed to go ahead and be something that you can do things like attach scripts to monitor other objects or help manage your game state. So I'm going to change its name to Game Manager, and then I'm going to add a component. And I'm going to see, it already has it typed in, but I'm going to look for a new script. And then it wants to know, okay, what do you want to call this script? I'm going to call it Game Manager Script, just to be consistent with what I'm creating here. Go ahead and press Enter. And you'll see down here in Assets, it has created the Game Manager Script. And on the Game Manager itself, it has added the component Game Manager Script. Now, in either of these areas, I can go ahead and do this, but go ahead and double-click the Game Manager Script, and Visual Studio will go ahead and automatically open. We'll go ahead and just give this a second. Okay, so this is exactly what we'd expect to see with a fresh script in Unity. It's got our basic using statements, namely the using Unity engine. It has our public class. Remember, the script name and the class name must match. And it automatically is extending mono behavior. And then it gives us our start and update functions. Now, the first thing you need to know about working with files in C# is that files are part of the input-output library. And that makes sense. You're inputting or outputting information, whether to or from a file or some other data source. So you need to add to the using statements using system.io. And then we want to go ahead and we're going to create a function called private void. We'll do a private void create file function. And let's go ahead and start with that one. Now, whenever our application starts up, we want to call create file. Okay? And we're going to go ahead and put in a debug.log. I created a file. Debug.log, if you don't know, is how you go ahead and print in Unity to the console right here. Okay? So, when our Game Manager script class first runs and it calls its start function, it's going to call create file. Create file is going to print to the console, I created a file. Now make sure you save the file, go back to Unity. You may see it like there, it hiccuped just a little bit visually because it was recompiling. Now let's go ahead and let's run the project. And there it is, I created a file. can go ahead and terminate the game. Now, that doesn't do us much good, so let's go ahead and... Now, there are a couple different ways you can read and write files. We're going to use streams. And for those of you who have done this before, I'm going to be using Stream Reader and Stream Writer. Okay? Now, we're creating a file. So, we're going to first start off with, let's tell the project, hey, right, using the file library, file.create, and we'll just call it log.txt. Okay? You saw there that the file object, okay, gives me a file stream. And I do create. Sorry, create gives me the file stream. And one of the parameters is it just wants a path to the file. Now, there are two kinds of ways you can go ahead and give it the path to the file. You could go ahead and give it this, okay? Or I could be specific and say things like, users, Chris, log.txt. Okay? Now, this is the fully qualified path. Okay? This right here is going to go ahead and I'm saying I have a specific location I want this in. However, if I go and give this to another person to run this game, they may not have a C drive users Chris. Okay? So when it goes to create log.txt, this will go ahead and throw an error. So I don't want to put this in as my location for my string. Okay? Instead, I want to use this. This is called a relative path. Okay? Relative, fully qualified. Okay? Now, a relative path is saying wherever my game is running from, whatever folder on the computer the application runs from, start there, and then create my file from that location. So if I were to have said, put it in, say my game is running in C users, okay, it's already in this folder, I could just say, okay, well, hey, go stick this in the Chris folder and call it log.txt. Then this would put it in that same place. In this case, it's just going to dump the log file in the root folder of my project, okay? Which is totally fine because now I know wherever my project is created on whatever computer, whether it's Mac, Windows, or Linux, it should go ahead and create it just fine. Okay? Now, when you're dealing with things like mobile and all that, you'll need to make sure that this is allowable, but in our case, this is going to go ahead and work out. Now, let's go ahead and save this. Okay? Go back to Unity, and we're going to run it. Okay, no errors, everything's going to be fine. We'll terminate the game, go to the folder, and let's see, there it is, log.txt. There's the file that we told it to create. Yep. Now if we go back to Unity and we run it again, okay, see, no problems, didn't do anything, no errors. It doesn't create the file again, it's just still right there. However, we don't know what this is going to do to that file. Is it going to go ahead and throw an error? Is it going to go ahead and crash? So I'm going to just open that file and manually type the word content, save it, and close it. And then we're going to run it. Now let's stop it, go back and refresh, open the file. See, it went ahead and erased my content. It created a new file. That's something to be aware of here. If you tell it, hey, create this file, it's going to go ahead and let's back up here a little bit and just say, okay, um, it's not going to tell you whether it's going to go ahead and recreate that file or delete it. If you were in Visual Studio, it would give you a bit more information. Or sorry, not Visual Studio. If you were creating a different kind of project, not a Unity project, it might provide you with some more information. But in this case, we have no way to know what's going on here. So that's one reason why you always want to create it, or go ahead and test it rather. However, a better way, rather than to go ahead and assume that you need to test it or that it's going to work one way or another, would be to do it like this, which is instead, let's go ahead and erase all this and say, hey, if file.exists log.txt, okay? Now, rather than saying if it exists, let's do something, we're going to put a exclamation in front of there to say not. If file does not exist, exists returns a boolean, as you can see right there. Bool file.exist string path. That little bit of the variable type in front of it tells you what it's going to return. This function will return a boolean. If the file exists, it'll say true. If it doesn't exist, it'll return false. So if file does not exist, then we want to do file.create log.txt. Now, another thing to be aware of is this works differently in Unity than it does elsewhere. But when you create a file, it doesn't automatically close the stream to that file. You open that file, it is being utilized. Okay, its resource on the computer is being utilized. So it's always good to say, let's close the stream after we create it. We're just going to go ahead and we're going to create it. We're not going to do anything with it. So let's immediately chain together our events and say file.create. And then for the returned file, we want to go ahead and call its corresponding close function. Okay? That right there, we'll go ahead and we save this. Let's go ahead and let's delete this file. Go back to Unity. And we're going to run it. I'm going to turn it off. Okay, there's our log.txt, totally empty. This is my new content. Save it. Close it. Go back to Unity. Run it. Okay, close it. Refresh the file. And you'll see this time it didn't delete my contents because it saw that the file already existed. Okay? So it did not need to go create the file. We don't want it to recreate the file unless that's something you're purposefully trying to do each time they run the game. Okay? Now, let's go ahead and look at the next step here. We have our log.txt. Okay? This is hard-coded. Say, while we're working on our game, we go, no, we need to go ahead and change this. We need to store the file someplace else. We need to go ahead and we want to modify it from the UI over here. Well, this won't really work. So let's go ahead and we're going to create a public variable. Okay? Public string file path. Okay? And we're going to give it a default of log.txt. Okay? And then down here in our function, we're going to change it. So that file path is a variable. Okay? This function takes a string. We are now giving it a string, and we're giving it file path. Save this file. Now the benefits here in code are that I can change this right here, this string, and it will update all the places that I'm using file path. In Unity, the bonus to making it a public variable is that over here in the game manager script, it recognizes that variable, file path, and it pulls in the default. I could go ahead and I could change this here to say log-info. And when I run my game, it's going to run the code to say, hey, go create this file. And if it doesn't exist, create it. Refresh, there it is, loginfo.txt. You can ignore these errors here, by the way. This is something to do with a Photoshop plugin that is recently been caused by an update to Unity and Photoshop on my system. So just ignore this, any error you see here about PSD importer. All right, so we now have it creating a file if the file doesn't exist. Great. Now we want to go ahead and look about actually putting content into our files. Okay. Now, we're going to go ahead and we're going to write two new functions here. Private void read file, okay, and private void write file. Now we're going to start with the read file. Okay. We're going to use something called a using statement. Now using statements are nice because using statements will go ahead and make use of a resource, and that resource will only exist while the using statement's loop is going. So as soon as we exit the using statement, the resource is automatically removed from memory. Okay? The nice thing about doing that with file streams is that it will automatically close your stream to the file once you exit the using statement. Therefore, you won't end up with a file on your system that is locked because your game claims that it's using it even if it really isn't. So again, we're doing read file, so we're going to do stream reader. We're going to create a stream reader object. So we defined it, we're instantiating it, and stream reader wants, as one of its parameter options, the file path. So we're going to use the file path variable we created. So now what this is doing is, once it hits the using statement, on the fly it's going to create a stream reader object called reader. It's going to instantiate it using the file path variable, so it's going to point to either our default log.txt or whatever we have entered here in Unity. And it's going to let us go ahead and start reading from the file. Now, I'm going to go ahead and skip to something here that a lot of people are going to run into this problem, and rather than make you suffer trying to figure it out on your own, I'm going to tell you. One thing you want to check when reading a file is, well, reader dot end of stream. Okay. Now, this is a function, so I'm going to do that. And what we want to say is, well, it is not the end of stream. Sorry, not a function. Well, it is not the end of stream. Do this. Okay. So while reading the file, we haven't reached the end. Keep reading. As soon as we go ahead and reach the end of the file, it detects that there is no more data in the entire file. And this includes white space, empty lines. It'll recognize those. But once we get to the end of the file, we will exit this while loop. And then as long as we don't have anything after it, we'll get to the end of the using statement and exit the using statement and close our connection to the file. So while we have not reached the end of the file, we'll do, debug.log reader.readLine. And all this is going to do is it's going to read the line from the file. Yeah, from the reader object, it's going to read each line from the file and print it to the console. So let's go ahead and, to see this in action, let's go ahead and go up to our start. Now, we want it to start by creating a file if it doesn't exist. We're then going to call read file. Now, let's say we just created a file. There was no file yet, and we just created it. And then we call read file. That's fine. It's going to go ahead and see that there's nothing in the file and not write anything to the console. We don't have to worry about that. So go ahead and save all of this as it is. Switch back to Unity. And let's go ahead and we're going to update our file path one more time. We're going to call it file read. Okay. Go ahead and save and then run. Now, nothing printed. We wouldn't expect it to, because it should have created a new file for us, and yes, it did. Okay. And there's no content in it. Now let's go ahead and we're going to add content. I'm going to just put a couple of the ABCs in here, A, B, C, D, E, F, G, H, I, J, K, and then I'm going to save the file. Okay. In fact, I'm going to go ahead and put the cursor on the next line. Okay. See how my cursor is blinking on the next line? That's good to know because when you write to a file, typically you're going to write to a line and it'll automatically insert a new line. So by me putting that in here already, I'm doing something I'd expect my code to do. So save the file and close it. And now go ahead and let's run it again. A, B, C, D, E, F, G, H, I, J, K, all the way down. So my code ran. It called create file. When the game manager came into existence, it called its start function, called create file. Create file said, hey, file's already there. Don't need to create one. Done. And then it called read file. And read file went ahead and said, okay, I've created a connection to the file. Until I reach the end of the file, I'm going to just keep reading this and reading each line. You can go ahead and think of read line as a queue. It goes ahead and just keeps moving down the line from front to back. So from the top of the file all the way down, it's automatically pulling things off the front of the queue. Okay. And then when it ends up getting to the end of the file, it stops trying to read it. We exit this function, the stream is released, we're no longer holding that file, that resource in use, and our game just keeps going, waiting for us to do whatever we want to do next. Let's go ahead. Now, that is our reader. Let's go ahead and we're going to open log read, and well, actually let's go ahead and let's take a step back. Let's not touch log read yet. Let's go down here to write file. Okay. We're going to likewise create a new using statement. Now instead of using a stream reader, we're going to use a stream writer called writer because I'm so original. And we want that writer to be associated with the file path variable. Okay. And we're just going to tell it writer.writeLine, and I'll just hardcode something here. Here, better yet, I'll put this in a loop. I'll say for int I equals 0, I is less than 10. Go ahead and write I.toString. Now, depending on where you're at with C#, a couple things just happened here. I created a for loop, okay? And here's the next for loop. I'm saying for, start with an integer I, starting at 0. While I is less than 10, perform this loop here, whatever's inside my curly braces, and at the end of each loop, increase I by 1. Okay? And then I said, all right, using my writer object, write a line to my associated file, and to that line I want to write I, and I want to convert I to a string. Most objects in C# have a toString method. They can go ahead and be converted to a string. Now sometimes that'll be logical, like the number 1 will become 1, and other times it may be that you have an array, and when you write that to a file, the built-in toString will just go ahead and literally write the words array to the file. Okay? In this case, it's okay, we're just writing a number. It can easily convert a number from things like 1 to 1. Okay? And let's go ahead and save this. Let's go up here to our start method. We're going to call writeFile. We're going to comment out readFile. So just put 2 forward slashes there, save it. So now when our code runs, it's going to create a file, and then it's going to write to said file. If we go back to Unity, we're going to change our file path variable. Instead of log read, it'll be log write. And let's go ahead and run it. If we close this, go to our code, there should be a log write file. Yep. And if you open it, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 through 9 was written to the file, which matches what our code is doing right here. This whole bit. Now, what we've just done here, you can go ahead and use this code almost exactly as is, and in just a regular C# project, something like WPF, WinForms, anything like that, you can go ahead and in any other software that allows you to access the built-in libraries for C#, system.io, you could go ahead and use this. You can go ahead and see more examples of the different ways to read and write files on some example code folders that I've gone ahead and linked in elsewhere, both in the description of this video and in different places that I've put this video. But that right there gives you the most basic idea of how to read and write files when working with C# and working from within Unity. Okay?